Okay, so in this question, we need to find the equation of the line that's tangent to this function at this point. Now, let's think about this. What information do we need to find equations of lines? Well, we either need 2 points or a point and a slope. Notice we have 1 point. If we could just find either another point or the slope, we'd be in business. But we know a little bit about calculus now. We know how to take derivatives, and what are derivatives but formulas that give us slopes of tangent lines? So that's where we should start. Let's take the derivative of f. Of course, the derivative of f is found in a rather straightforward way. We just bring the power down and lower the power by 1. Here we do the same thing. The exponent here is a 1, so that just becomes plus 1 times 3, or 3. And when we lower it, we have an x to the 0. Of course, anything to the 0 power is 1. So we can just leave that as a plus 3. And minus 2, of course, being a constant, when we take the derivative of that piece, that goes away. So this is the derivative. Now, it tells us the slope at any x value. We are just interested in what the slope is doing at this point of tangency, at x equals 0. Okay, so at x equals 0, we know that f prime of 0 here is just 2 times 0 plus 3, which of course is 3. So that's the slope we need. We have a slope m of 3, and we have a point at 0, negative 2. Okay? If we have a slope and a point, we can very quickly get to the equation of the line using the point-slope form. So this is y minus the y-coordinate, so that's y minus a negative 2, or y plus 2, equals the slope, which in this case is 3, times, in parentheses, x minus the x-coordinate. Well, that would be x minus 0. Okay, of course, there's no real reason to write minus 0 here. Let's tighten this up by just saying y plus 2 equals 3x. And for that matter, just so it looks like it's in a nice form, say slope-intercept form, let's solve for the y. Let's take the 2 to the other side and get y equals 3x minus 2. And that is the equation of the line tangent to this function at this point. That's it.